Null vector and unit vector. Null vector, a vector whose modulus is 0. A vector whose magnitude is 0, whose modulus is 0, whose modulus is 0 is known as a null vector. Modulus p bar is equal to 0. This is the modulus of a vector p bar. If it is 0, then it is called a null vector. The direction cannot be determined for a null vector. So the direction is indeterminate. The direction cannot be determined. It is indeterminate. Then unit vector. A vector having magnitude of 1 is known as unit vector. If the magnitude of a vector is unity, it is called a unit vector. A unit vector will be obtained by dividing the vector with its magnitude. So if p bar is a vector, the unit vector will be p bar by modulus p bar. P bar by modulus p bar gives unit vector. Generally, modulus p bar will be represented by p. So the modulus will be represented by p. Hence, it can be written as p bar by p. Here, modulus p bar should not be 0. To obtain unit vector, modulus p bar should not be 0. Hence, p bar by modulus p bar gives unit vector. That means a vector having magnitude unity along the same direction of the vector p bar. So the unit vector has the direction of p bar, but its magnitude is 1. Unit vectors, orthogonal unit vectors. We represent 3 unit vectors along x, y and z axis. They are named as I, j, k. We take 3 unit vectors along x-axis, y-axis and z-axis. The unit vector along x-axis is termed as I, small I. The unit vector along y-axis is termed as j, small j. And the unit vector along z-axis is taken as small k. These are known as unit vectors along x, y, z-axis. Use of unit vectors. How the unit vectors are useful? The unit vectors are useful in representing a vector in terms of its components, x component, y component and z component. If there is a vector a bar whose x component is ax, y component is ay, z component is az, these are scalar quantities. Then the vector component along x-axis is written as axi. The vector component of a bar along x-axis is represented as axi. The y component of a bar is written as ayj. This is the vector component along y-axis. The vector component along z-axis is represented as azk. Axi, ayj and azk are the components along x, y, z axis. So the vector a bar will be equal to axi plus ayj plus azk. Like this, we represent a vector, we write a vector in terms of its components. Advantage of unit vectors. I will explain this. First, let us try to understand the figure. Here, I have taken 2 vectors a bar and b bar. I have constructed a bar plus b bar. A is represented from origin and b is constructed at the head of a bar, and the vector with tail of a bar and head of b bar gives the resultant vectors, that is represented by r bar. R bar is the resultant of a bar and b bar. Now let us write a bar and b bar in terms of their components. The components of a are shown as ax and ay. From the head of a vertical dotted line is drawn, and from y-axis its distance is represented by ax. This is x component of a bar. Similarly, from the head of a bar, a dotted line is drawn parallel to x-axis. The length of this, the height of this along y-axis, the distance of this from x-axis is given as ay. Along y-axis, its length is ay. So, ax and ay represent the components of a bar. Ax is along x-axis, ay is along y-axis. So, the vector a bar can be written as axi plus ayj. The vector a bar can be represented as axi plus ayj. Now, let us take the components of B. From the head of B, a dotted line is drawn vertically downwards, and Bx, the x component of B, will be from the dotted line at the end of A to the dotted line to the head of B. That is represented by Bx. That is represented by Bx. Another dotted line is drawn parallel to x-axis from the head of B. From the head of B, the vector from the head of A to the head of B along y-axis. Along y-axis is represented by By. So, the vector from the horizontal dotted line from the top of A to the horizontal line to the dotted line to the top of B is By. Now, B bar can be written in terms of its components. B bar is equal to Bxi plus Byj. B bar is equal to Bxi plus Byj. Now, R bar is equal to Rx bar. X component of R bar is equal to Ax plus Bx. R component of X is equal to Rx. Rx is equal to Ax plus Bx. And Ry is equal to Ay plus By. Ry is equal to Ay plus By. Like this, we find the components of R along x-axis and y-axis. Then, by computing Rx and Ry, by constructing Rx plus Ry, we will get the vector R bar, which we are going to study now. We have seen Rx is equal to Ax plus Bx and Ry is equal to Ay plus By. Therefore, R bar is equal to Rxi plus Ryj. R bar is equal to Rxi plus Ryj. X component is Rxi, Y component is Ryj. So, vector R bar is equal to Rxi plus Ryj. Therefore, R is equal to square root of Rx square plus Ry square. R is equal to square root of Rx square plus Ry square. And the angle made by R with x-axis, is given by theta, and tan theta is given by Ry by Rx. Tan theta is equal to Ry by Rx gives the angle made by R bar with x-axis. Like this, by using the components, we can find resultant of any number of vectors. The resultant of any number of vectors can be obtained by using the components.